Hi, I'm Jörg. I'm using technology to develop positive, cooperative, and effective animal training methods. In this video, I want to show you how I trained my dog to stay on its mat even when the doorbell rings and visitors come around. Untrained, the behavior typically looks like this. The dog is on his mat, the doorbell rings, and off goes the dog. The challenge in training this behavior is that I have to reinforce my dog when it's on the mat and not reinforce him when it's not in his mat without being in the same room. And this is where I want to leverage technology. From a machine learning perspective, that task can be broken down to the question whether I can distinguish this image from that image, which is a typical image classification problem. Still, as an additional challenge, I don't want to have a big, noisy GPU machine standing in my living room. So I want to implement all that on a small Raspberry Pi. And that is a point where Edge Impulse came into the game. So let's head over to their website and see how that worked. I created a new project, Dog on Mat, started with data acquisition, and that turned out to be pretty straightforward because I could just connect my smartphone to their website, make the photos with my smartphone, and they were directly in the web page, and that worked out nicely. I ended up with about 80 something photos, and the quality admittedly is not very good, but it is what it is. Training in test data looked like this. So in the next step, I created my impulse. And I started with a model which took only black and white photos, but that was changed later on, and I will come to that in one of the next steps. I use transfer learning using MobileNet as the base architecture, trained the network, and it turned out that the quality wasn't that good, so I used the Eon tuner to check with their better parameters, and in the end I came up with this one here, which classified my data, my validation data 100%. The whole thing ran in about 4 milliseconds with a really small memory footprint, and that's pretty nice. And as you can see, it classified all but one of the test data correctly, ending up with an accuracy of nearly 95%, which I think is pretty amazing, taking that we have only 80 photos, 40 for each class, and that the quality wasn't that good. Having trained this model in about half a day or something, I went over to the deployment page and used this tab here to generate my Linux libraries, which I then uploaded with the provided tools onto my Raspberry Pi. So let's see how that worked on the Linux side. I wrote a little Python script which just takes the input, does the inference, and then writes the result of the inference into the image. And so let's fire that up. And here we go. No dog on the mat. See whether we can change that. Twisty, Decke. And there's the dog, and the dog is on the mat. And we have a prediction of 99%, so that's pretty awesome. Let's see whether that also works when the dog goes down from the... Good. Auf. So now you can even see that the network only fires when the dog is really on its mat. Decke, and not when he's in the picture already, but not standing outside of the mat yet. Now, that worked out pretty nice, and now I started to integrate that into my training app. For the communication, I added some Bluetooth capabilities to my Python script. I started the script and it's now waiting for the connection to my smartphone. Let's do that. You can see my Raspberry Pi is showing up here already. It is connecting. We are connected. And the moment we are connected, the video here is displayed with a frame rate of about 20-25 frames per second, which I think is pretty nice. And if you now go back to the app, we can start training. And you see, as long as there is no dog on the map, nothing happens. So let's try again to get the dog on the map. Twisty? Decke? Auf. Decke? And you can see as soon as the dog is on the map, we have the classification here, and the timer starts on the app. So let's click and treat the dog for that.
6.
And the next timer runs because the dog is still on the map. And as soon as the dog leaves the map, okay, we have to pause for that. Oh. We get a classification that the dog is no longer in the mat. The timer is stopped. And if you go back here, we have the summary of our training session. Now at the moment, I'm still throwing treats around. In the end, I wanted to have the whole system working without me being in the room. So therefore, I had to add a feeder to it. To this end, I used a commercial feeder and used an Arduino board with a Bluetooth module to steer that. And the way I did that is pretty embarrassing because I just glued a servo on the remote of it. It's not very high tech, but it works. And now I can read the signal coming into the app via Bluetooth and send another Bluetooth signal to the feeder to treat the dog, even when I'm not there. Here you can see how the whole system works together. The AI sees whether the dog is on its mat or not. If he's on the mat, the AI will send a signal to the app, which will start a timer. After a variable time, the app will send a signal to the feeder, which will reinforce the dog. When the dog leaves his mat, the AI also sees that, sends the according signal to the app, which stops the timer, and waits until the dog is back again, then starts the timer, and after the appropriate time, will start the feeder. If you want to play around with the system yourself, I've put a link to the public Edge Impulse project in the description. There you can also find links to the app, which is freely downloadable in Google Play Store, and the source code is also freely available on GitHub. If you have any ideas or suggestions, please leave a comment. My next steps are now to bring the whole system from the Raspberry Pi to a smaller chip, like for example the ESP32 CAM. And of course to generalize the model so that it's not only my dog which is detected, but dogs in general. If you want to follow that, please subscribe to our channel.